Section 12.2 is rational expressions. So again, anytime you hear the word rational, you think of a ratio or a fraction. So a rational expression is an algebraic fraction whose numerator and denominator are both polynomials. I'll talk a little bit more about that in a second. The denominators of rational expressions may not have a value of 0. Anything over 0, 3 divided by 0, x plus 3 over 0. Anything over 0 is undefined. You cannot divide by 0, and so we cannot have rational expressions where the denominator is 0. So one of the things we're going to look at is finding excluded values. And excluded values are any value that would make the denominator of a rational expression equal to 0. We have to exclude those. They're not allowed. So a rational expression like 5x plus 3 over x minus 6, we cannot substitute any value of x that would make the denominator 0. So to find excluded values, we set the denominator equal to 0, and we solve for x, and we say that 6 is an excluded value. Any other value that we want, we can plug into this to get a value for the expression. So we can say that, for example, when x equals 1, the expression is 5 times 1 plus 3 over 1 minus 6, which is 8 over negative 5. We can get a value, but 6 is excluded from x values. Let's try another one. Again, we're going to set the denominator equal to 0. Go ahead and try this on your own. See if you can find the excluded value. Okay, so 2x equals negative 8. Subtract 8 from both sides. Divide by 2. And we get x equals negative 4 as our excluded value. Remember, this is not a solution to this. This is just what number do we have to omit when we evaluate this expression. We'll try a couple more. Now, the denominator of this one is a quadratic expression. We've been working on quadratics and setting a quadratic equal to 0 and solving it. So you should know that you have several choices here. We can factor to solve it. We can use the quadratic formula. Our negative b plus or minus the square root of b squared minus 4ac over 2a. Or we can use complete the square. Most of the time, we are going to try to look at factoring. So most of the time, we want to try and factor. Are there factors of negative 6 that add up to negative 5? Now remember, when I have positive 6, they have to either both be positive or both be negative. So in this case, I want the 2 and the 3, both negative. This is just our factoring step, like we did in the previous chapters. And then we set each factor equal to 0. And so our excluded values now are 2 and 3. There are 2 excluded values for this one. All right, one more for you to try on your own. Again, pause the video, give this a try. Okay, so the denominator cannot be 0. Whoops, write that correctly. Factors of 12 that add up to 7, I'm going to use plus 3, plus 4. So x plus 3, x plus 4, so negative 3 and negative 4 are my excluded values. And I cannot use either of those when evaluating this rational expression. All right, with all that said and done, now that we know what values we cannot use, let's look at some simplifying. We simplify rational expressions by finding common factors. When you simplify 8/6, the language that you typically use is to divide both of those by 2 to get 4/3. In reality, what we're doing is we are saying that 8 is 2 times 4, 6 is 2 times 3. When I multiply, I can cancel like factors top to bottom, because 2 over 2 times 4 over 3, this is just 1, and when I multiply 1 times anything, I have itself. So we don't go through all of this when we're just simplifying a numeric fraction, but when we have variables, we want to do some work here. So common factors, 7 and 21 both have a 7 in them. Both of these have an A. Both of them have a B. That's all. Now on the top, I still have another B factor because it was B squared. And on the bottom, I have a C factor, and I have a 3, because 21 was 7 times 3. The 7AB can all go away. That's all just a great big 1. 7AB over 7AB equals 1. And I have B over 3C as what is left over, or my simplified value. Okay, let's try this with some other things. Factor first. Everything must be factored before you can cancel. Do not try to cancel before you factor. It is very tempting to cross off this x squared and this x squared. But those are not factors. Those are terms. Remember the difference. Two things or pieces joined by addition and subtraction, these are separate terms. The only way I can cancel things is to cancel factors. I need something times something to be able to cancel. Multiplication, not addition. This is really, really, really difficult to remember. And it's extremely tempting to cross off those x squareds, but do not do it. So we are going to factor everything first. That's going to be your mantra, your chant. Factor first. I have to factor the top and the bottom, just like I did on the last slide when I had monomials. One piece monomials. I had to factor them. So I'm going to factor the binomial. To factor a binomial, I pull out my common factor of x. Now I have a multiplication problem. At the bottom, factors of 12 that add up to 7. We did this one already. X plus 4, x plus 3. There's my multiplication. So on top, I have two factors, x and x plus 3. On the bottom, I have two factors, x plus 4 and x plus 3. These two factors, the whole thing, the x plus 3 and the x plus 3, can be canceled, leaving me with x over x plus 4. Excluded values. I need to do the excluded values before I have canceled. Although this is the simplified version, the original back here had excluded values of -3 and -4. The factors set equal to 0. Now I kind of jumped around, but let's go back and think. Factor first. The factors on the bottom are set equal to 0 to find my excluded values. Doing all the work. Most of you can do this in your head at this point. So -4 and -3 are my excluded values. Once I've factored everything, found my excluded values, then I can cancel any like factors and get a simplified. What this means is that for any values except for -3 and -4, if I plug the value into the original, I will get the same as if I plug it into the simplified version. So let's try that. Let's say that x equals 2. My original would be 2 squared plus 3 times 2 over 2 squared plus 7 times 2 plus 12. That's 4 plus 6 on top, which is 10. That's 4 plus 14 plus 12 on the bottom. So that's 30, and this equals 1/3. If I plug 2 into my simplified version, I get 2/6, which is also 1/3. So clearly it's easier to find values for different x values using the simplified version, but remember, both of these are excluded. We'll talk a little bit more about that when we look at graphs as well. If you plug this into your graphing calculator as a y equals, and you plugged the simplified in as a y equals, they would look identical except at -3 and -4. And we'll talk, as I said, we'll talk about that more when we do graphing. All right, the last one I want you to try on your own. Factor it first. Look for excluded values, then cancel like factors to get your simplified version. All right, hopefully you've tried this on your own. 3 times x minus 5 on top. My factors on the bottom are x minus 5, x minus 2. If you didn't get this for your factors, pause it again and try to go on from here. Okay, excluded values. Setting the denominators equal to 0, I would get 5 and 2. Those are my excluded values. Continuing on to cancel like factors. My factors on top are 3 and x minus 5. Those are my two factors. On the bottom, my factors are x minus 5 is my first factor, x minus 2 is my other factor. So I can cancel my factor of x minus 5. And my simplified version is 3 over x minus 2. So a lot of factoring. If you were shaky on factoring the first time through, I suggest you go back and look at your notes or come to see me for